Hey everyone, Mr. Prevet here. Excited to do some more calculus with you. It's going to be a great day. We're looking at FRQ number 4 from 2023. We got a graph of f prime, which is super common. Just looking at this, we got some concavity. We've got a limit, absolute minimum, relative minimums, and maximums. Should be a really fantastic question that tackles a lot of different topics all rolled up in one. So this should be a fantastic opportunity to learn. But let's look at it together. So we've got this graph, we got a couple of line segments, a semicircle, and it's a graph of f prime. And the question says, the function f is defined on the closed interval, -2 to 8, and satisfies that f of 2 is equal to 1. The graph of f prime, the derivative of f, consists of two line segments and a semicircle, as shown in the figure. Okay, so let's look at part A. Part A, excuse the voice crack. But part A, it says, does f have a relative minimum, a relative maximum, or neither at x is equal to 3? Give a reason for your answer. Now, what we know about relative minimums and relative maximums is this. A relative minimum happens when a function goes from, think about it for a half second, I'm struggling, decreasing to increasing. And a relative maximum happens when the opposite happens, increasing to decreasing, right? So when our derivative goes from negative to positive versus when it goes from positive to negative. Now, looking at the graph, this is the graph of f prime, the derivative, right? On the left side of 6, my derivative is positive, right? It's above 0, it's less than 2, and it approaches 0, and at 6, it looks like it hits it. But on the right side of 6, my derivative is also positive. So I'm going from increasing to increasing, even though f prime equals 0 at x equals 6. So this is an example of a critical value that is not a relative extrema, right? It's not a relative minimum. It's not a relative maximum. It is neither. So that's our final answer for part A. I would just say it's because our function goes from increasing to decrease, or increasing to increasing. It is not a minimum or maximum. So answer choice A, not too bad. Just gotta understand those extrema, right? But let's move on. Part B. So part B says, on what open intervals, if any, is the graph of f concave down? Give a reason for your answer. Now, we have a function f. We know that a function is concave down if our second derivative is less than 0. Now, this graph of f prime of x, right? That's what we're looking at. We're not looking at a graph of f. So, looking at the graph of f prime, what represents the second derivative? Give you a second to, lock in your answer in your head. Well, it's the slope, right? It's the slope of the function, the tangent line at a point. So, looking at this graph, I'm just looking for where the slope of the tangent line is negative. And it looks like, to me, those intervals are from -2 to 0. Slope is negative. And then that second line segment, it's positive from 0 to 4, right? But then at 4 and all the way till 6, our tangent line is negative once again. And then it's positive from 6 to 8. So because my first derivative, or this is a graph of the first derivative, well, my slope of the tangent line is negative on these intervals. So therefore, our function is concave down. So that is our final answer for part B. Not too difficult. Honestly, I think part A and B here are like extremely gettable. All of us should really be hoping to get these. And, scoring wise, there is a reason. Those two parts combined are only worth 3, right? Nowhere near the amount of points that are still left to get on C and D. I think C and D for this question are both worth 3 points. So most of the points to be gained are coming right up. But if you made it this far, just want to thank you guys once again for watching the videos. Appreciate y'all's support. It means a lot to me. I love making these videos, teaching y'all about calculus. Comment if there's anything beyond like these FRQs that you would want me to look at in the future. I would love to just be a resource for you guys to really grow your skills in calculus. But let's move on. Part C, we've got a limit. I really love limits. I don't know about you guys, but it says find the value of the limit as x approaches 2 of 6 f of x minus 3x divided by x squared minus 5x plus 6, or show that it does not exist. Okay, well, we have a limit, right? We know our very first step to solving a limit is direct substitution, right? Just plug it in. So if I plug in 2, I get 6 f of 2 minus 3 times 2, which is 6, divided by 2 squared minus 5 times 2 plus 6. Now, at the beginning of the question, like kind of in the question itself, it says that f of 2 is equal to 1. That was the only initial condition that they gave us. So f of 2 is equal to 1. So that's 6 times 1 minus 6 divided by 2 squared, which is 4, minus 10 plus 6. When we look at those, both of those are equal to 0. So when we direct substitute, we get 0 over 0. Does that mean that my limit does not exist? No, this is just an indeterminate form. 0 over 0 and infinity over infinity are both indeterminate forms, right? There's something that we need to do to these functions in order to actually be able to solve the limit. Now, one of those things that we can do is factor, we can rationalize, but the most powerful tool of all that involves calculus is L'Hopital, right? And that's where I can take the derivative of the numerator and the denominator and do the same limit, and that limit will be equal to this initial limit that we found. So I'll take the derivative of the top and bottom. The derivative of 6 f of x is just 6 f prime of x minus 3 divided by the derivative of this is 2x minus 5. So now I plug it in. I get 6 f prime of 2 minus 3 divided by 2 times 2, which is 4 minus 5. Now we've got this f prime of 2. How do we solve for it? Well, the great thing is they gave us the graph of f prime. So looking at 2, our value of f prime is equal to 0, right? So I just get 6 times 0 minus 3 divided by negative 1. So that equals negative 3 divided by negative 1, which is equal to 3, which is our final answer. So remember, for limits, right, we direct substitute. If we get just a normal value or something over 0 that isn't 0, we're done, right? But if I get an indeterminate form, I should use L'Hopital, factor, rationalize, whatever tool. Normally, L'Hopital is the best, especially in calculus. And then once we do that, direct substitute once again and get the value. So that is our answer to part C, right? So Let's move on to the final part. This one, so far, honestly, I feel like this FRQ is one of the easier ones on this like whole 2023 test. I think all of the parts are like super doable. Nothing really there to like throw you off intentionally. But let's look at part D. It says find the absolute minimum value of f on the closed interval from -2 to 8. So we're trying to find absolute minimum. And there are two places that these can occur, right? Those places are endpoints, and they can also occur at relative minimums, right? That's where my function goes from decreasing to increasing. So looking at this graph, there's actually only one relative minimum, and that happens at x is equal to -1. That's the only place where, oh, I'm so sorry. I messed that up, like, entirely. No, my relative minimum happens when my derivative goes from negative to positive, right? Decreasing to increasing. And that happens at x is equal to 2. We had a relative maximum at -1. But at x is equal to 2, you can see I'm below the x-axis, and boop, my derivative goes above the x-axis. So I go from negative to positive. So that's my relative minimum. My endpoints are just the endpoints of the interval. So x equals -2 and 8. So in order to figure out the absolute minimum, what I'm going to do is use something called the candidates test. And that's where I check the value of the function at all of these points. When I solve for all three of these, I just compare, figure out which one's the greatest, and whichever one is the greatest is my final answer, right? Not too crazy. Or, oh my gosh, I messed it up again. I switched it up. We're looking for the absolute minimum, so whichever one of these is the smallest will be our final answer. Now, the great thing is f of 2 was already given to us. It's equal to 1, right? That was given to us at the beginning of the problem. Now, f of -2, f of 8, these look a little bit more challenging, right? Now, the great thing about solving for the value of the function at these points is that I can use a definite integral. And here's how, right? What I'm going to do is set up an integral from a point that I'm going to solve for to a value that I already know. I already know f of 2 is equal to 1, right? And when I integrate f prime of x, which is the graph that I have right here, this represents the area, right, beneath the curve from -2 to 2. If the area is above the x-axis, it contributes positively. If it's below the x-axis, it contributes negatively towards the integral. And using the first fundamental theorem of calculus, this is also equal to f of 2 minus f of -2, right? So I can solve for these things separately, right? For f of 8, I can do the same thing. Look at the integral from 2 to 8 of f prime of x, and that will equal, you guessed it, f of 8 minus f of 2. And I already know f of 2. I can solve for both of these by looking at area under the curve, and boom, I can solve for it, right? So let's start with this integral from -2 to 2. Well, from -2 to 2, I kind of have this first triangle. I wish I like had the graph to segment it out. I'll draw kind of like an example of it, right? So I've got this point, it dips down, goes down to here, and then over to there, right? So the first thing I need to do is solve for the area of this triangle. It has a base of 1 and a height of 2, so that area is equal to 1. So, my integral from -2 to 2 of f prime of x equals 1. And now I need to figure out this part. The base of this triangle is equal to 3. Height is equal to 2. So the area is equal to 3. Just 3 times 2 over 2. But this is below the x-axis, so it will contribute negatively towards this integral. So this value of the integral is equal to -2. And that's equal to f of 2 minus f of -2. F of 2 is equal to 1, so -2 equals 1, minus f of -2. F of -2 is equal to 3. So boom. Now we can compare these two, right? And we see that the only possibilities here are, we got f of -2 is equal to 3. Well, that's definitely larger than 1. So now the only thing that I need to check is 8, right? So let's check 8. So for f of 8, I'll try and draw out the picture once again of this function. It's a little bit more complicated for this one, but it's like a triangle up to here. And we have a semicircle to there. Do not make fun of my drawing skills. But I can split this up into kind of these two separate intervals. This first one has just a triangle, base of 2, height of 2. The area is 2. And it is above the x-axis. So the integral from 2 to 8 of f prime of x dx, I forgot to put the dx up there, but it's 2. And now I need to find the area under this curve, right? And the way I can do that is by creating a rectangle, taking the area of the rectangle, and then subtracting out the area of the semicircle. The height of the rectangle is 2. The width is equal to 4. So this rectangle's area is equal to 8. The area of the semicircle, the radius 2, is equal to 1/2 pi times 2 squared, which simplifies down to 8 minus 2 pi. And it's above the x-axis. So it'll be 2 plus 8 minus 2 pi. And that's equal to f of 8 minus f of 2. Gosh, the Sharpie's giving me issues. But f of 2 is equal to 1. So that's 1. So I'll write it again. 2 plus 8 minus 2 pi is equal to f of 8 minus 1. Adding it over, I get 1 plus 2 plus 8, which is 11, minus 2 pi is equal to f of 8. So now I have all three values, right? Looking at these, pi is about 3.14, right? So this is definitely going to be greater than 1. So our absolute minimum value of f is going to be 1, right? So that is our final answer to this question, part D. A little bit of a mess looking at part D. There's a lot of work that goes into this. Now, I do want to mention one thing, specifically for solving for f of 8, right? We know that this integral from 2 to 8 of f prime is equal to f of 8 minus f of 2. Now, if this integral that I find is positive, well then f of 8 minus f of 2 is positive. F of 8 is greater than f of 2, and therefore f of 2 is smaller and is the absolute maximum, right? Or absolute minimum, sorry. And looking at this integral, our entire function is above the x-axis. So this integral is 100% going to be positive. So just based on that, before we even solve for a value, we definitely know that f of 8 is greater than f of 2. And therefore, f of 8 can't be the absolute minimum value of this function. But that's just kind of a conceptual take on a question that you can do like with rigorous calculus, right? But that is it. Difficult final part. The first three parts were really reasonable, I think, but a difficult final one. But I hope that this video was super helpful and just encourages you, to work more on your calculus skills and grow in your understanding of it. But it was great talking to you guys. I hope that you have a fantastic day, and I'll see you in the next video.